excited that we're going to alternation, aren't you?
Yeah, I'm so excited.
Oh no, I missed our turn.
Just take the next turn, it's fine.
Take the next turn? I'll just turn right here onto 2nd Street. Oh look, there's something on the street sign.
Let's check it out.
Function on this sign.
I wonder what this function could mean. Maybe since this was our first turn, we can find the first degree polynomial of this function, and then that will give us the max error if we plug in 2 for 2nd Street. And it will also tell us how many more miles till our next turn.
So the problem is f of x equals sine of x. So let's generate the sine of x series first. Sine of x equals x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. Since this is our first term, we are going to use the first degree polynomial to find our error. Now when you find the error of an alternating series, you always go to the next term. So we're going to actually use the 3rd degree. So we have x cubed over 3 factorial. And since we're on 2nd Street, we're going to plug in 2. So we get 2 cubed over 3 factorial, which equals 8 over 3 factorial. 3 factorial is 6, so we have 8, 6, which becomes 4 thirds. So now we have 4 thirds miles to our next turn. Now that we've traveled 1 1/3 miles, I'll alternate the way that we're turning and I'll go left. Oh look, there's another sign on this street sign. This one looks a little harder. I don't know if we can do this.
No, it's actually easy. You just have to have memorized the cosine function. So basically, since this is our second turn, we're going to use the 2nd degree polynomial of the cosine of 4x function. And I think we're going to plug in a quarter because it's quarter street. And then that will give us our max error for this function, and it'll tell us how many miles till our next turn.
Our second problem is f of x equals cosine of 4x. So let's start by generating the cosine series. F of x equals cosine of x. The cosine series is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and so on. But we want cosine of 4x, so wherever there's an x, we're going to plug in 4x. So our new series is 1 minus 4x squared over 2 factorial plus 4x to the 4th over 4 factorial minus 4x to the 6th over 6 factorial, and so on. So since we are on our second turn, we want to find the error for the first 2 terms. But in order to do this for an alternating series, we have to go to the next term. So we're going to use the 4th degree term of the series. So we have 4x to the 4th over 4 factorial. And since we are on quarter street, we're going to plug in 1/4 for x. So we have 4 times 1/4 to the 4th over 4 factorial. 4 times 1/4 is 1. So we have 1 to the 4th over 4 factorial, which equals 1 over 24, which is how many miles we have until our next turn. We're here 1/24 of a mile, and I'll go right this time. And it looks like there's one last clue on this street sign. It's our last one. We're so close to alternation. Nat, how do you think we should solve this?
Well, this is our third and last turn, so we're going to use the 3rd degree polynomial of this function. And then we're going to plug in 1 because it's one lane, and that'll give us the max error of this function, and it will tell us how many more miles until we get to alternation. Yeah!
Our third and last problem is f of x equals 8 ln of 1 plus x. So let's start by generating ln of 1 plus x. So the series for ln of 1 plus x is x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4, etc. And now we're going to multiply each term by 8. So we have 8 ln of 1 plus x equals 8x minus 4x squared plus 8 over 3 x cubed minus 2x to the fourth, and so on. Since we are on our third term, we want to find the error for the first 3 terms. But since it's an alternating series, we have to go to the next term, which is 2x to the fourth. And since we are on one lane, we're going to plug in 1 for x. So we get 2 times 1 to the fourth equals 2, which means we have 2 more miles till our final destination.
Yay!
Look, we're here. It's alternation.
I'm so glad we know how to find error in an alternating series, or we never would have gotten